Something enormous is sitting inside a rocket in Florida right now. It isn't a spacecraft designed to carry astronauts. It isn't heading to the moon. And it isn't another version of Hubble simply taking prettier pictures of space. It is a telescope designed to survey enormous portions of the universe while searching for answers to some of the biggest questions in modern astronomy. And in just a few days, NASA plans to send it into space. The Nancy Grace Roman Space Telescope is currently preparing for launch from Kennedy Space Center. NASA is targeting liftoff for 7:26 a.m. Eastern Time on August 30th aboard a SpaceX Falcon Heavy rocket. And once Roman reaches its destination, scientists aren't simply expecting another collection of spectacular space photographs. They're expecting an entirely different way of looking at the universe. Because Roman is being built around something Hubble and Webb were never designed to do in quite the same way. See enormous areas of the sky quickly, deeply, and in extraordinary detail. And that difference could matter enormously. For decades, astronomers have faced a basic problem. The universe is enormous. Even the part we can observe contains billions of galaxies. Those galaxies contain stars. Those stars contain planets. And between all of them is an enormous amount of dark matter and dark energy that we cannot directly see. Astronomers have learned an incredible amount from telescopes like Hubble and James Webb. But many of their observations involve looking deeply into relatively small portions of the sky. Roman is designed to approach the problem differently. Instead of concentrating primarily on tiny pieces of the cosmic landscape, it will survey enormous regions. NASA says Roman's field of view will be at least 100 times larger than Hubble's. Think about what that means. Imagine looking through a camera that can capture a small section of a landscape. You can study individual trees in extraordinary detail, but if you want to understand the entire forest, you eventually need a much wider view. Roman is designed to provide the wider view of the universe, and that is where this mission becomes much more interesting than simply another telescope launch, because scientists are trying to answer a question that has bothered cosmologists for decades. Why is the universe expanding the way it does? We know the universe is expanding. We also know that the expansion has been accelerating. The mysterious phenomenon associated with that acceleration is called dark energy. But despite its enormous influence on the universe, we still don't know exactly what dark energy is. We don't see it directly. We infer its presence from its effects on the cosmos, and Roman is being designed specifically to help scientists investigate those effects. It will map huge numbers of galaxies and study how cosmic structures are distributed across space and time. By observing how those structures evolved, scientists can test competing ideas about dark energy. Is dark energy a constant property of empty space? Has it changed over cosmic history? Or is something more fundamental happening with our understanding of gravity and the universe itself? Roman won't necessarily answer all of those questions immediately, but it could provide an enormous amount of new evidence, and that's important, because sometimes the biggest discoveries don't come from one spectacular photograph. They come from collecting millions or billions of measurements and finding a pattern hidden inside them. Roman is built for exactly that kind of science. NASA says the telescope could measure light from 1 billion galaxies over its lifetime. That is an almost absurdly large data set. And every galaxy becomes another piece of information about how the universe evolved. But dark energy is only one part of the mission. Roman will also investigate dark matter. Dark matter is another cosmic mystery. Unlike ordinary matter, it doesn't appear to emit, absorb, or reflect light in the way normal material does. We don't see dark matter directly, but we can see its gravitational influence. It helps shape galaxies. It influences how large-scale structures form. And it appears to make up a substantial portion of the matter in the universe. Roman will be able to map the distribution of matter across enormous regions of space. One of the techniques scientists will use involves something called gravitational lensing. Gravity can bend light. When light from a distant galaxy passes through regions containing large amounts of matter, the path of that light can be distorted. The effect can be subtle, but across billions of galaxies, those tiny distortions become incredibly useful. They can reveal where mass is located, including mass that we cannot see directly. So Roman will effectively be looking at the universe and asking, where is the matter? How is it distributed? And how has that distribution changed over billions of years? But there is another part of Roman's mission that may be even more immediately exciting to the public. Planets outside our solar system, exoplanets. Astronomers have already discovered thousands of them. Some orbit stars similar to our sun. Some are enormous gas giants. Some are small rocky worlds. Some orbit so close to their stars that their surfaces may be completely hostile to life as we know it. And some occupy regions where temperatures could potentially allow liquid water under the right conditions. But discovering an exoplanet is one thing. Actually seeing it directly is another. A planet orbiting another star can be incredibly difficult to observe because the star itself is vastly brighter. Imagine trying to photograph a tiny candle sitting directly beside a stadium floodlight. The candle exists, but the floodlight overwhelms the image. Roman includes a technology demonstration designed to address part of this problem. Its coronagraph instrument will test techniques for suppressing starlight and directly imaging nearby exoplanets. This doesn't mean Roman is guaranteed to photograph an Earth-like alien world. And it doesn't mean NASA expects to discover extraterrestrial life. That would be going far beyond what the mission can promise. But the technology could represent an important step toward eventually being able to study planets much more directly. And that distinction matters. Because the biggest question isn't simply how many planets exist. We already know there are enormous numbers of them. The bigger question is, what are those planets actually like? Roman could help astronomers move toward answering that. But before any of this can happen, the telescope has to leave Earth. And right now, that's where the mission stands. NASA has already completed the flight readiness review. The telescope was encapsulated inside the Falcon Heavy's payload fairing on August 21st. Then, on August 24th, the entire encapsulated observatory began moving toward the launch complex. On August 25th, NASA reported that Roman had arrived at the SpaceX hangar at Launch Complex 39A. That means this isn't a distant proposal. The telescope is physically at the launch site. The rocket is being prepared. The countdown is approaching. NASA's current target is August 30th, and if everything proceeds according to plan, Falcon Heavy will lift Roman away from Florida and begin sending it toward its final destination. But Roman won't simply enter a low orbit around Earth. After launch and separation, the telescope will travel toward the second Sun-Earth Lagrange point, known as L2. That's approximately 1 million miles from Earth. At that location, Roman can operate in an environment that is particularly useful for astronomical observation. And once it arrives, the telescope will begin a complex process of deployment, testing, calibration, and commissioning. The first spectacular images may not arrive immediately. That is important to understand. Space telescopes don't simply launch and start taking perfect pictures the next morning. Their instruments need to be checked. Their systems need to be calibrated. Their mirrors and detectors need to be verified. Their pointing systems need to be tested. Scientists have to make sure that the telescope is operating exactly as intended. Only after that process will the major scientific surveys begin. And when they do, Roman's greatest strength may not be a single image. It may be the sheer scale of what it observes. Imagine astronomers receiving enormous maps of the universe containing countless galaxies. Then imagine comparing those maps with earlier observations. They can search for patterns. They can measure distances. They can track how galaxies cluster. They can look for gravitational distortions. They can search for explosions and variable stars. They can identify planets. They can study structures that existed billions of years ago. And because Roman is designed to survey such large areas, it could reveal things that smaller surveys simply miss. That is where unexpected discoveries often happen. When you look at a small region of space, you're more likely to find what you were specifically searching for. But when you scan enormous areas, you also increase the chance of finding something nobody was looking for. A strange object, an unusual galaxy, a rare gravitational event, a previously unknown population of planets, a pattern that doesn't match existing models, or something that forces scientists to reconsider an assumption they've held for decades. That is one of the most exciting aspects of Roman. Not necessarily what scientists already know they will find, but what they don't know they're going to find. And history tells us that wide-field astronomical surveys can produce exactly those kinds of surprises. The universe has a habit of refusing to behave exactly the way we expect. That's why Roman's mission is so important. It's not simply another camera pointed at space. It's a new way of collecting evidence, and the scale is enormous. NASA says Roman's primary mission is planned for 5 years, with a goal of operating for as long as 10 years. Its science data will ultimately be made publicly available after processing. That means this isn't just a launch story. It is the beginning of a scientific data set that could continue growing for years, and the discoveries won't necessarily come from NASA alone. Astronomers around the world will eventually be able to work with Roman's observations. Different researchers can analyze the same data, looking for completely different things. One team might study dark energy, another might search for exoplanets, another might investigate galaxy formation, another might look for rare transient events, and someone else may notice something nobody expected. That is how modern astronomy increasingly works. The telescope collects the evidence, scientists ask questions, computers search enormous data sets, and occasionally something appears that doesn't fit. That moment can change everything. And Roman is being designed to increase the number of those opportunities. There's also something symbolic about the telescope's name, Nancy Grace. Roman was NASA's first chief astronomer and played a major role in making the Hubble Space Telescope possible. She became known as the mother of Hubble. Now, decades after Hubble transformed our view of the universe, a telescope carrying her name is preparing to launch with a very different mission. Hubble taught humanity to look deeper. James Webb pushed into infrared astronomy and the early universe. Roman is designed to look wider, and that combination could be powerful, because understanding the universe requires both approaches. Sometimes you need to zoom in, sometimes you need to step back. Roman is the step back, the enormous cosmic survey, the telescope trying to see the forest instead of just the trees. And if everything goes according to schedule, that process begins in just a few days. But there is one thing we should not do. We should not assume Roman will launch and immediately prove one particular theory about dark energy. We shouldn't assume it will discover life. We shouldn't assume it will find an Earth twin. And we shouldn't assume every mystery will suddenly be solved. Science doesn't work that way. What Roman can do is something more valuable. It can dramatically increase the amount of evidence available. And sometimes that's exactly what science needs before a major breakthrough becomes possible. More observations, more galaxies, more planets, more gravitational measurements, more cosmic history, more opportunities to catch the universe doing something unexpected. So on August 30th, when that rocket rises from Florida, the important thing isn't just the launch itself. The real story begins afterward. 1 million miles away, a new observatory will eventually begin looking across enormous regions of space. And somewhere inside, that data will be billions of galaxies, countless stars, thousands of planetary systems, dark matter-shaping structures we cannot see, and evidence about a force we still don't understand, dark energy, the thing driving the accelerated expansion of the universe. For decades, we've known that something strange is happening. Now we're sending a telescope specifically designed to investigate it on an enormous scale. And maybe Roman will confirm what current theories predict. Maybe it will narrow down the possibilities. Maybe it will reveal a problem with our current understanding. Or maybe somewhere inside those enormous surveys it will find something completely unexpected. That's the possibility I find most exciting, because the greatest discoveries are often not the things scientists already know they're looking for. They're the things that appear in the data and make everyone stop. The things that force a new question. The things that make scientists say, wait, what is that? And in just a few days, NASA is preparing to give astronomers another opportunity to ask that question. The Nancy Grace Roman Space Telescope is at the launch site. The mission has passed its flight readiness review. The observatory is enclosed inside its rocket fairing. And NASA is currently targeting August 30th for launch, so this isn't simply another telescope being sent into space. It's a new survey of the universe, a search for answers about dark energy, a massive experiment in mapping dark matter, a new tool for finding and studying exoplanets, and potentially a machine for discovering things nobody expected. Something is about to change in the way we see the universe, and the countdown has already begun. If you want WideView to follow what Roman discovers after launch and to break down the strange things scientists find when the data starts coming in, subscribe to WideView now. Because sometimes the biggest discoveries don't begin with a headline. They begin with a telescope looking somewhere we've never looked closely enough before, and somewhere in that view, there may be something we've never seen, something changed, scientists noticed, and WideView will be watching what happens next.